Hello everyone and welcome back to What the Heck Math. Today we're going to answer the question, what the heck are monomials? Okay. Monomials. So monomials, for example, this is a monomial. And we're going to focus on rules of exponents, how exponents work, how to add, subtract, multiply, and divide monomials, and also how to simplify monomials. So let's get started. Okay, so first let's go over exponents. So an exponent, for example, x to the power, see I picked the wrong pen there, here we go, x to the power of 3. So x to the power of 3, this is equal to x times x times x. Now you'll see here, whenever I use multiplication, I will not be using the x symbol because it gets confusing with the letter x. I'll be using the dot to show that we're multiplying. So x times x times x, so it's 3 times, and if it's x to the power of 4, that's going to be x times x times x times x. Very simple. Now, one thing you got to be careful of is something that often confuses people, is if I were to do minus x to the power of 3, it's important that this minus x is in parentheses. Because what that means is everything within this parentheses is going to be multiplied by itself 3 times. So it's going to look like this. Actually, let's change this up. Let's, instead of minus x to the power of 3, let's do power of 4, because it helps us explain this issue a little bit better. Okay, so minus x times minus x times minus x times minus x. Now, if I did not put parentheses and I put just minus x to the power of 4 without parentheses, what this is equal to is minus 1 times x to the power of 4. So this minus is not raised to the power of 4, just the x is raised to the power of 4. So that means this is going to be equal to minus 1 times x times x times x times x. And you can see how that's going to give you a different value if instead of x we actually had a number. Okay, so we could, just to be really simple, we can say minus 1 to the power of 4. So in parentheses it's minus 1 times minus 1 times minus 1 times minus 1. And yeah, we can put that in parentheses. So minus 1 times minus 1 is 1. So this would be 1 times 1, which is positive 1. Now if we instead did parentheses, or didn't do parentheses around it, it would give us a different answer. So if I did minus 1 to the power of 4 without parentheses, this is going to be equal to minus 1, and this minus 1 comes from that negative, times 1 times 1 times 1 times 1, because only the 1 is raised to the power of 4. So then this will give us a value of minus 1. So it's important to understand what the difference is when you have parentheses around the base of the exponent. So this would be the base and this would be the exponent. So when there's parentheses around it, that means that entire value, everything within the parentheses, is raised to that power. When there are no parentheses around it, it's just what is right next to the power that is raised to that power. Now let's also look at what happens whenever we start multiplying exponents. So for example, x cubed times x squared. Now you can rewrite this as x times x times x, so that's from the x cubed, times x. And you can see there are 1, 2, 3, 4, 5 x's, so this is going to be the same as x to the power of 5. So what we basically did is we added the exponents. So when you're multiplying 2 together, you just add the exponents. Now you can only do that if the bases are the same. For example, x cubed times y squared is not equal to xy to the 5th, because the bases are the same. You're not going to combine them. So you only combine it when the bases are the same. Now, another way to look at this, you can also do x squared cubed. So these are 2 powers, x squared and then whole thing to the power of 3. So you can say this is going to be equal to x squared times x squared times x squared. Each one of these x squareds is x times x, so x times x. times x times x times x times x. And so you have 1, 2, 3, 4, 5, 6 x's. So that means this is equal to x to the 6th. And what we did here, we didn't add them, we multiplied. So if you're multiplying two exponentials with the same base, you add the exponents, and if you're taking something to a power to another power, you then multiply the exponents. So let's do a practice problem that uses this real quick. So for example, we're going to go pretty difficult here. So we'll do all of this cubed. Okay. Now, you could write this as everything in here times itself again, or you can just distribute this 3 across each one of the pieces on the inside. Okay. So now there are 1, 2, 3, 4 things that are raised to the power of 3. 4 things that are multiplied by each other. Now it's important that this power of 3, because this negative 3 is inside the parentheses, it applies to the entire negative 3. So that means we can take minus 3 to the power of 3, and then we're going to multiply by x to the power of 3 to the power of 3 times y squared to the power of 3 times z to the power of 3. And now we can simplify this. So this negative 3 to the power of 3, that's going to be equal to minus 27. X to the power of 3 to the power of 3. We're going to multiply these powers. That's going to be x to the 9th. Multiply these powers. Y to the 6th. Now, z, when there's nothing there, it's assumed there's a 1. Because z to the power of 1 is equal to z. So that means we can multiply these powers. 1 times 3 is 3. So z cubed. And there's our answer. So that's one way you can simplify exponentials. Now, we still haven't answered the question, what the heck is a monomial? Well, pretty much this whole time we have been dealing with monomials. Okay? So let's define what a monomial is. Well, it starts with the word mono, which essentially means one. Not essentially, it does mean one. So a monomial is one term. Okay? So a monomial can be 3 things basically. It can be a constant. So for example, 2, 3, 10. Okay, so any number. It can be a variable. So x, y, z. Or it can be a product of a constant and a variable. So like 2x or 3x y squared. The important thing is, as long as there's no addition or subtraction, if there's only multiplication and division, then it's a monomial. Because once you have addition and subtraction, like 2 plus x, these are each a monomial, but this is not a monomial. It's what's called a polynomial, and that'll be covered in a different video. So monomials are just one term. There's no addition, no subtraction, just multiplication or division. So let's do some multiplying and dividing monomials. So if we want to do x squared times 3x to the 6th. Well, this is 3 times x to the 6th. So this is essentially, you can rewrite this as x squared times 3 times x to the 6th. And you can just combine these in any order that you like. Now with monomials, you usually put the coefficient or the constant that's multiplied in the front. You don't put it anywhere else. It always goes in the front. And if there are multiple coefficients, then you just combine them with multiplication. So we're going to move that 3 into the front. And now we have x squared times x to the 6th. Now what do we do with these two numbers? We add them together. So that's going to be x to the 8th. Okay, now what about dividing? Okay, we've multiplied them together, but we haven't divided yet. So let's divide two monomials. Let's use the letter p. We haven't used that yet. So let's go p to the power of 9 divided by p to the power of 5. Now let's write these out. So we're going to expand these so it's no longer a power, but we're going to treat them as multiplication. Let's see if I have enough room here. So it's going to be p times 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 p. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Okay. Now those are all multiplied together. Divided by p times p times p times p times p. Here's 5. Now, if I were to have just p over p, they would cancel each other out, because that just equals 1. So let's see how many of these we can cancel out. Well, we can cancel that one and that one. We can cancel that one and that one. That one and that one. Cancel those. Cancel these two. And now we're just left with 4 p's. So that means this is equal to p to the power of 4. Now how do we get 4 from 9 and 5? Well, we subtract. 9 minus 5. So when there's division, you subtract. So when there's multiplication, you add the powers. When there's division, you subtract the powers. Now again, just like with multiplication, this only works when you have the same base for each of them. If this was p and this was q, you would not do anything. You could not simplify that any further. Now one thing interesting about this rule is it explains this rule. What's x to the power of 0? 1. Anything to the power of 0 is equal to 1. Now let's see why that is. Because if you think about it, saying x to the power of 0, that essentially means x times itself 0 times. So why isn't it equal to 0? Well, let's see if we can make this make sense using this rule. So for example, what if I had x squared over x squared? Now, that would be equal to x times x over x times x. That cancels, and we're left with just 1. Well, let's figure this out using this same rule that we did over here. So it's going to be x to the power of 2 minus 2, which is x to the power of 0. So this is equal to x to the power of 0, and it's also equal to 1. So that's why anything to the power of 0 is equal to 1. Now, the one exception is 0 to the power of 0. That's actually undefined. Maybe I'll cover that in another video. Okay, well these are monomials. This is just a basic introduction to monomials, how to multiply and divide monomials and simplify them. Hopefully it was helpful. If it was, please give it a thumbs up. If it wasn't, I would feel free to comment to give me any suggestions for what you would want to see in a future video. If you do like this, please subscribe, and I'll see you next time.